Hello, ladies and gentlemen, and welcome back. We're looking in this video at question number 3 on our 2019 Hypatia paper. All right, so the arithmetic mean of two positive numbers x and y is half the sum of the two numbers, or x plus y over 2. The geometric mean is the square root of their product, so square root x, y. There are other means out there, but these two are quite common, so they're good to know. Every once in a while. There's actually a very nice result. I don't know if we're going to need this, but it's called the arithmetic mean geometric mean inequality, or AMGM. It says no matter what x and y you pick, the arithmetic mean is always greater than or equal to the geometric mean. I don't know why the word escaped me there for a moment. So this is nice. GM it tends to be called. I don't know if we'll need it because it's not the most common thing for people to know, but we'll see it, and if I need it, I'll prove it. Okay. So we got two light bulbs and a written A part. What are the arithmetic and geometric means of 36 and 64? Okay, so do we understand the definitions? Yep. Add the two numbers up, divide by 2, add them up. It's going to be 100 because this is a well-known 6, 8, 10 arithmetic triple. So the arithmetic mean is 50. The geometric mean square root. I noticed that there's squares. I'm not going to multiply them out. I'm just going to say, square root and squares cancel out, so it should be 6 times 8, 48 geometric mean. Okay. So there we go. Probably 1 mark for that, 1 mark for that. B part. Determine a pair of positive real numbers whose arithmetic mean is 13 and geometric mean is 12. Okay. So x plus y over 2 needs to be 13. Square root of xy needs to be 12. Let's square that. So xy needs to be 144. Let's say x plus y needs to be 26, and let's rearrange. Let's say y is 26 minus x, and then we can plug it in here. We should get a quadratic. 26 minus x times x is 144. 26 minus x squared is 144. So 0 is x squared minus 26x plus 144. So I might use the quadratic formula, but instead, can I factor this? Minus 12 and minus 12 multiply to 144, but don't give me 26 when I add them up. Minus 24 and 2 don't work. Maybe minus 18? 18 and 8, is that? Yeah, so we'll have x minus 8, x minus 18. So x could be 8, or x could be 18. And remember, y is 26 minus x, so y is 18, or y is 8. So either way, 8, 18 is such a pair. Okay, so here we go, pair of numbers, 8 and 18. Okay, C part. Now this is one way we actually have to write our answer. Show all our work. For two positive integers, x and y, the arithmetic mean minus the geometric mean is equal to 1. Well, we have that in the last question, actually. Determine with justification all such pairs x, y, where x is less than y, strictly less than y, and less than or equal to 50, and we are looking at positive integers. So I guess technically we should also have this. Okay. Let's do something like that. Let A equal the arithmetic mean. Then we're told the geometric mean is 1 less than A. Okay? I guess we could sort of do the same technique. 2a is x plus y, and xy is going to be a minus 1 squared. And then we can say, well, y is 2a minus x, and plug it in here. X times 2a minus x is going to be a minus 1 squared. So that's a squared minus 2a plus 1. And then we can expand over here, 2ax minus x squared. Bring everything over to the one side, x squared minus 2ax plus a squared minus 2a plus 1. Well, that's got to be 0. Now I think we should probably use the quadratic formula just because I don't... Will there necessarily be a way to... No, I don't think it should work, because I mean 8 and 18 aren't really that well related to the 13 or the 12, not in an obvious way that I can think of. So yeah, I think quadratic formula. So by the quadratic formula, x is negative b, so that's 2a plus or minus 2a squared minus 4. A is 1 in this case. C all over 2a. I should be able to divide by that 2 pretty quickly. 4a squared minus 4a squared plus 8a minus 4. So this should be 8a minus 4. I'm going to take out a factor of 4. So I can write it here, and then it can come outside the square root sign at the cost of square rooting. And then all that's over 2, but if I just divide by 2, we get our answer here. So for x to be an integer, we need 2a minus 1 to be something squared. Okay. We also need... So if they want x to be less than y, that implies that 2a minus 1 isn't 0. That's not going to be that big a deal because, well, a would have to be 1/2 in order for these two values to be equal, and that's certainly not going to happen. Because then x plus y would have to be 1, and there's no way that's going to happen. But we do know a is the smaller of the two values, and y must be the larger of the two values. Now we also have a limit for 50. So keep that in mind, but what can k be? Oops, sorry, this should be a minus 1. Good, we caught that. So what can we have if this is a plus k, this is a minus k. So for my k value, we can get our k squared. Actually, 1, I'm running out of room for this chart, but 2, if 2a minus 1 is k squared, we see k squared is odd, because it's an even number minus 1, and so is k. So that actually limits the k's that I need to check, because there's got to be some upper bound. So k could be 1, 3, 5, 7, 9, 11, 13. Eventually, we're going to run into problems because y limits us. Y has to be less than 50. So square k, and you'll get k squared. Add 1 and divide by 2, and you'll get a. So for example, if k is 1, a is 1. then we can actually work out x and y. A minus k, 0, and a plus k, 2. So this one doesn't work out, because x is 0. That's not allowed. 9 plus 1 divided by 2 is going to be 5. So we'll have 2 and 8. Just do a quick check. 2 and 8, the average is going to be 5. The geometric 2 times 8 is 16, square root is 4. So yeah, that one definitely works. You see y has already jumped up by 6. We'll get a is 13. This should be our 8 and our 18. Oh, that's kind of interesting. 2, 2, 8, 8, 18. Maybe there is a formula. Maybe there is a nice little expression here. Anyway, 49, add 1, divide by 2, 25. 25 minus 7 is 18. 25 plus 7, 32. Looks like y is twice k squared. And x is twice k minus 1 squared. That's what it looks like anyway. Or k minus 2 squared. There we go. Anyway, we can keep going. 32 is getting close to 50. So 81, add 1 is 82. Divide by 2, 41. Subtract 9. Oh, look at that. It's 32. Add 1 is 50. And that should be our limit, because the next one should be 61. We'll go up by 20 there. Go up by 16 there. But 61 minus 11 should be 50. And then your y is 72. And that's certainly not allowed. So we get 4 different possible pairs. That's all they wanted. Just how many pairs? Determine with justification all such pairs. Well, there we go. We got a nice little chart explaining them. So it could be 2 and 8, 8 and 18, 18 and 32, and 32 and 50. So these are the only possibilities. Just more generally, if x is 2 times... Well, let's be a little nicer. Let's say 2k minus 1 all squared, and y is 2 times 2k plus 1 all squared. This should work out. Right? Because then we'd get... this is just based off my observation with these numbers. 8 is twice a square. 18 is twice a square. Actually, this is twice 3 squared. This is twice 2 squared. This is twice 1 squared. So it's not quite this formula. So let's say 2 times k squared, 2 times k plus 1 squared. So 2k squared, and then 2k squared plus 4k plus 2. If you add those up, four k squared plus 4k plus 2, and divide by 2, you'll get 2k squared plus 2k plus 1. And then we should get 2k squared plus 2k for our geometric mean. Let's check that out. So 2k squared, 2k plus 1 squared. So the 2's become a 2 squared. And like in the in the A part, the squares and the square roots can cancel out. So 2k times k plus 1, and that is 2k squared plus 2k, which is 1 less. Okay, that's kind of nifty that that's how it works. And I think you could probably take what we've learned here and prove that this is the only way it could work. That's kind of nifty. All right, anyways, we'll leave it there, and up next we're going to take a look at, we're at the end of the Hypatia already. It's going to be question number 4. We'll take a look at that next time. Take care.